So let's look at a question from 7.5 for the population proportion. So remember, we have these guidelines that we need to follow as we move forward. Uh, make sure that we do pass the test. N times P is greater than or equal to 5 and N times Q is greater than or equal to 5. And then we can state our null hypothesis and alternative hypothesis. And then we have our identify our level of significance and then determine our critical values. Again, we're not going to use a table. We're actually going to use our calculator using inverse norm, which is under the distribution menu. And then the standardized statistics, we're not going to use this formula either. We're actually going to, again, use our calculator, and we're going to go to where it says one prop C test, and that's under our test menu under stats. So we're going to use some calculator things here. And then using this, we're going to decide whether or not to reject or fail to reject our null hypothesis. So looking at question 7, an education researcher claims that 57% of college students work year-round. In a random sample of 600 college students, 342 say they work year-round. At a level of significance of 1%, is there enough evidence to reject the researcher's claim? Completes A through D. So let's just kind of go through these questions here. So the first thing it says do is identify the claim and state H sub 0, the null hypothesis, and H sub A, which is the alternative hypothesis. So again, identifying the claim, the education researcher claims 57% of the college students work year-round. So that looks like an equality. So it looks like we're going to be saying here, 57% is going to be going in our little box there. So you'd be filling that in. And as far as stating the null and alternative, so we would be using an equality. So the null hypothesis, since we're talking about a population proportion, would be using P as our test, our parameter. So P would equal then 0.57. And then our alternative hypothesis, we'd be saying P does not equal 0.57. And remember, our claim is actually the null hypothesis. So this is where our claim is as we move forward. So the next thing it says do is find our critical values and identify our rejection regions. So this is where you find your zeros. And I think in your homework, I think they're asking you to round it to 2 decimal places. So a lot of times I'll do my drawing. Here's 0 here. Remember, that's the mean. So if I try to draw this, now remember when we do this, we have to figure out is this left-tailed, two-tailed, right-tailed. And since it's does not equal 2, that kind of tells me this is two-tailed. So to do this, though, I need to know what alpha is. And our level of significance was 0.01. So our level of significance is 0.01. So we have to find the test statistic for this region here, and then the test statistic for this region over here, since it's two-tailed. So we actually have to have 2 critical values. Now, remember, since it's two-tailed, we actually have to divide alpha by 2, the level of significance by 2. So what is half of 1%? And it'd be like, what, 0.5% or 0.005. So 0.005 would be our alpha we'd actually have to use. So again, what I usually do is just find the area to the left of negative z0 here. Because you remember the way the table works and the way the calculator typically works, it's just it does the area to the left. So if I do the second distribution, that gives us our menus for our inverse norm, number 3. the area is going to be this 0.005. And again, since we're doing standard normal distribution, the mean and the standard deviation are both ones standardized. Left tail, that looks good. So then our test statistic, if we go 2 decimal places, we're going to be saying negative 2.58. And then remember, since there's 2, the positive one is going to be, C0 is going to be positive 2.58. So we have that as our critical values. Now, as far as our rejection regions go, notice that we have to be left of negative 2.58. So one of them has got to be, Z0 has got to be less than negative 2.58. We also have Z0 has got to be greater than a positive 2.58. So that's going to be where we're going to be rejecting. So if you're in those areas there, then we're going to be rejecting. So from there, so like I said, this is going to be where you would use your inverse norm here to find the critical values. And again, that's located under the distribution menu. So inverse norm. So then we actually have to find our test statistic. So keep in mind there is a formula up here that we're supposed to use to find our test statistic. And we're not going to use that formula. We're going to actually use the calculator for this. So remember, this is going to be under test. And we're going to be using, I think it's called the one prop Z test. One prop Z test, I believe is what we were saying. So one prop Z test. So let's see what we need to know to do the one prop Z test. So if we go to stat, that's where the tests are located. One prop Z test is number 5. We need to know the population proportion. That was the 0.57. And then the next thing we needed to know was from here, the number of successes. Notice that in our sample of 600, 342 say they do work year round. So the 342, they gave us that. We didn't have to do any math there. But notice how there were 600 students there. And this was, it does not equal to. So it looks good. So if we calculate, we do get our Z statistic, which is 0. So that's actually the mean. So the Z test statistic is just Z equals 0. So it's actually the mean itself. So does it fall in the rejection region? And we recognize that this does not fall in the rejection region. So this tells us to fail to reject H to 0. So that's what's going to go here is we're going to fail to reject H to 0, the null hypothesis. So fail to reject the null hypothesis. Now from there, this is where this little table comes in. Again, that I think that's in some of this. I think the photo that 7.1 has this little thing in here. So, but if you get confused, because I've got confused several times in my videos of how to phrase things. So again, remember if the claim is H is 0, we always use wording involving reject. If the claim is the alternative hypothesis, we always use wording involving support. So that's kind of the pattern that we pick up on. So for ours, our claim was the null hypothesis. And we said we failed to reject the null hypothesis. So what we're kind of doing is we're saying this and this. So it leads us to say this right here. So there is not enough information. So there is not enough evidence, if you will, not enough information to reject the researcher's claim. Okay, so since we're not rejecting, there's not evidence to reject the claim. So that's kind of where that leads us to. So that's always a little tricky with the wording. So this little box here, this little table can kind of help you piece that together again if you have trouble with that. But again, if the claim is the null hypothesis, the phrasing is always directed towards reject, has the phrasing of rejections tied into the wording. It just has to make sense. And then if the claim is the alternative hypothesis, the phrasing has to have the word support in it, but it has to make sense. So that's kind of where we are with hypothesis testing there. So hopefully you found that useful.